Okay, so this is a sort of a pre-demo. I'm actually not getting to the meat of the instructions yet, but I wanted to show you something. When you're doing this lab, I'm going to have to time jump the lab significantly, I think, because as you're doing this lab, you're going to spend what you'll do is you'll create a basic TCP dump, and then you'll start filtering. So this is my first attempt, TCP dump, and then you've got your timestamp format. The four T's I think gives you your date, your hour, your minutes, your second, and including down to a very, very precise fraction of that second, and then you see the basic protocol. In this case, IP and then ARP, and then you can see the uh, source and the destination. You can see, in some cases, the transport protocol in use and the length of the packet. Now, this doesn't tell you anything about the contents of the packet, but it does tell you more or less what it's trying to do. Now we can start filtering some of this. Say, for example, these first four lines here. I'm going to want to filter those. Sorry. Okay. I'm going to want to filter these. There's a couple things here. One, that port 1900 is probably part of my baseline. Um, that is a universal plug and play port. The other thing here to note here is the target, the destination address. 239, 255, 255, 250. That's in the in the multicast range. If you remember from your network fundamentals class or CCNA 1, um, the five classes of IPv4 address: A, B, C, D, and E. A is your very large networks from effectively from 1 to 126 in the first octet. B is your medium-sized networks from 128 to 191. C is your smaller networks from 192 to 223. Class D is the multicast range from 224 through 239. 240 to 255, that is Class E, the experimental range, and we don't worry about that. So I can ignore this multicast. Another thing I can ignore is these next two lines here. UDP port 53, that's DNS. That is actually my host bouncing information off the hypervisor itself, because the hypervisor is serving as a pass-through, shall we say, for DNS and indeed everything else. Then I've got some ARP stuff, this here, these next two lines, ARP. I want to ignore ARP, because I'm not interested on things that are happening on the local subnet. Because I've only got these two hosts up. I've got my Debian client and my Ubuntu desktop. I've got nothing else going. When I'm good and ready to test this, I'll actually bring my Kali system up and use it as a platform to scan. Probably by the time I will have done this, I'll have both of these up, Debian and Ubuntu. I'll do both of them. On the other hand, there are some things that I can see that are interesting. Now this 35, 224, 99, 80, I'm going to keep watching that. So what I'm going to do is filter. We're going to basically create a very long, complicated Boolean filter, not ARP and not port 253. Notice it doesn't tell us whether it's TCP or UDP. It's just taking the port and closing it off, and not port 1900. And then you'll iterate on this. You'll figure out what normal is, and you'll filter all those things out. If you're looking at the instructions, now what he's doing here, and now I'm using sudo because TCP dump is a fairly powerful program. It reaches down into the protocol stack, so you may need sudo privilege for this. What he's doing is not VRRP, and not STP, and not ARP, and not some other things. VRRP is the Virtual Router Redundancy Protocol. It is an open first hop redundancy protocol. This is something you'll probably get to in CCNA 3. If you're in my CCNA 3, we talked about this earlier in the semester. If you're in, you might also discuss this in your routers course or enterprise networks. STP is the spanning tree protocol. This is something you'll probably see in either the TCP/IP course or the routers course. For those of you in CCNA 3, we covered it earlier this semester. ARP, Address Resolution Protocol. Also, not net. So you're telling it to ignore the local IPv6 link local traffic. I haven't actually seen anything from IPv6 yet. If I do, I'll close it off. But I'm not going to feed this thing any more than I need to. Now, one other thing. The first part of your instructions, install Wireshark and TCP dump. Now, this -y flag at the end is kind of new for us. What that does, that -y flag tells apt-get to just go ahead and install it. You know how you do apt-get, it downloads the packages, it tells you what it wants to do, and then it asks for permission. The -y flag here gives that permission right off the bat. What you can actually do, if you wanted to, is do both of the, actually, if you knew for a fact that the system you were installing these programs on didn't have either one, you could actually feed it both of these at the same time. So it would get Wireshark and TCP dump and all of their dependencies. When I did this for myself a few minutes ago on my Ubuntu system, it told me that TCP dump was already there. So I didn't have to do that. Another thing you can do if you're trying to figure out what your IP address is, you can actually use the hostname command. You can use the IP address command, and you can go look for inet line for the inet line, or really and truly, if you want your IPv4 stuff, you could do IP-4 address show, and it'll only tell you IPv4 stuff. And then you can grep even further, grep for inet or something like that. So it'll ignore it'll filter out all the layer 2 stuff. It'll filter out all the IPv6 stuff. Very useful. So what I'm going to do, and so as you can see, it took me a while. So this first scan took me about 2 minutes. And then the next scan I let it go for, well, not very long at all, honestly. But before it started spitting that out, it waited for a while. So what you're going to do is iterate over this TCP baselining process. If this takes you 30 minutes to an hour, don't worry. What you're doing is generating information about what normal looks like on your system so you can safely ignore it. Thanks, and I'll be right back.